Hello. So I was on mute. Thank you, Tanja, for letting me know. Okay, good. So anyway, to all of you, Happy New Year. Maybe a good one with lots of success, happiness, and health and peace. And let's start with our first CEE Swiss Impulse session of the year. I'm very happy that we continue this series. And also very happy to have Tanja Zimmermann with us today. I'm personally a big fan of Empa. And so it's for me personally a big pleasure to have her with us today and hear what they are doing. As usual, I also wanted to thank our partner organizations of the 12 Swiss chambers of commerce in the CEE region. We are trying to do this as a joint project and to bring very interesting content, hopefully inspiring content about new technologies, new developments, etc., into Switzerland and to those 12 countries. And so thanks a lot for the co-organizers. And I also wanted to mention that, of course, these chambers of commerce do a lot more to improve the relationships between Switzerland and those countries. So I would like to invite all of you to check out what they are doing and join the efforts in order to push forward our great relationships between our countries. Now, I also would like to very quickly give some pointers as usually. So we'll have potentially around 25 to 30 minutes from Tanja about the topic at hand. You are always on mute, so we don't see you, we don't hear you. So if you want to be heard, please write into the chat function. You can also tell us where you're from. We are trying to stop on time, which will be 11:45. If there are ongoing questions, we will, of course, continue with that for a couple of minutes more. Use the Q&A function if you have questions at any point during the webinar. Ask your questions, and you will receive the slides and the contact details and more about Empa in our follow-up email. And you can also rewatch the session on our YouTube channel. And that's about it from my side. We don't have the next topic yet. We all start slow into the new year. So I hope, like me, you had a good break, and we will come up with other interesting topics quite soon, and we'll inform you about this. So without further ado, let me introduce you to Dr. Professor, well, the other way around, Professor Dr. Tanja Zimmermann, a distinguished figure in the field of material science, I can say. So since June 2022, Professor Zimmermann has been leading Empa, which is the Swiss Federal Laboratories for Material Science and Technology. So maybe, in the region, not so many people know about Empa, maybe even in Switzerland, I don't know. But they do really great stuff. And by doing this, Tanja is the first female director in its 140 year history. So congratulations there. Her pioneering journey in this field began with a PhD from the University of Hamburg in 2007, where she laid the groundwork for technical applications of cellulose. Professor Zimmermann's illustrious career at Empa started with her focus on wood-based materials. Based on she made an approach in this, what I would also consider a little bit a niche field, into a globally recognized research area. Under her leadership, Empa's Applied Wood Materials Lab has made significant strides, particularly in developing new wood-based materials for various applications, including 3D printing of biodegradable structures for sensor and energy applications. So that's quite complex for me as a marketer, I have to say. Her work has, however, been pivotal in advancing the field of cellulose and nanocomposites in Switzerland, emphasizing the development and production of functionalized wood and cellulose-based materials. These materials have found applications in diverse areas such as adhesives, packaging, and even ecological and sustainable alternatives to conventional materials. As a professor, which is also of material science at both ETH Zurich and also EPF Lausanne, Professor Zimmermann continues to contribute to academia. Her dedication to topics like circular economy, resource efficiency, and the pursuit of net zero goals underline her commitment to sustainability in material science. And apart from that, she also serves on various national and international committees, scientific advisory boards, and research commissions. Today, we are very honored to have her to share insights. So, Tanja, please, the floor is yours.
Yes, thanks a lot, Oliver, for this really kind introduction. So I hope you can all hear me. I guess yes, so otherwise please tell me. So I hope that you are all a big fan of Empa then after the presentation, not only Oliver, and that it also changes that you know Empa then pretty well after my presentation. So I will talk about how we come with material innovations into a sustainable future and how material research can help to solve the current challenges we are facing at the moment. The figure you see here already demonstrates what we are doing. So we are starting from the idea, high level basic research, but always...
Tanja, quickly, we can't see the screen.
You can't see the screen?
Well, at least I can't. Let me see.
Okay. Mm-hmm. Okay. This is then, of course, a problem. I'm not sure if I'm really in. Should I go out once and come in again over the link?
Yes, I would say. Let's do that.
Okay.
Very
so
quickly.
Sorry for that.
No problem.
So now I'm...
So anyway, let me, I don't know. I'll bridge a bit. Tanja's back. Okay, now it should work. Try again.
Do you see it now?
Nope, that's strange. Maybe because you have different screens, potentially.
No, I have it on all screens I have here. I shared now. Oh.
Oh, that's crazy. We tested. So guys out there, we all tested this.
This is now really crazy. I try again.
Now we get there. Okay. Now we see the screen of Zoom. Good.
Now?
Great. Okay, good. All good.
So, but now it should work. So sorry for this. So now you can see it?
Perfect. Yeah, thank you.
This is great. So thanks again for the kind introduction. Sorry for this technical problem, but now we will start. So I will talk about material innovations and how we come with material innovations into a sustainable future and how material research can help to solve the current challenges we are facing. And what you can see here on the first figure, and now I try to get rid of this because this you will also see, is how we function at Empa. So we start from the idea, always having in mind what could evolve out of it, as we want to bridge research and applications, and then attracting with our knowledge industrial partners and develop together with the industrial partners until the proof of concept. And of course, we want at the end that our industrial partners earn money with what we are doing and what we develop. So we are doing cutting edge research with an impact, and this functions in such a way that we are doing interdisciplinary material science and technology development. What does this mean? So we are not working in single silos like single professorships. We have a matrix structure, and this means that we bring our competencies together to tackle complex problems and solving them. And what is also unique, and what I will show you later on, our technology transfer platforms, where we can also work on a demonstrator level and validate what comes out of our research, if this really functions in real world. We are about 1,000 co-workers at Empa, highly motivated scientists, engineers, technicians, other employees. And as I said, we are carrying out application-oriented research and technology development. So we want really to make an impact at the end and to bring our solutions to the market. Our mission is really that we are working on a more sustainable future that remains worth living, especially for our future generations. This is really important for us, and you will see this also with our research focus areas where we work in. So what you see here on the image is a young researcher who printed an artificial ear out of cellulose. So otherwise, I will not talk about cellulose today, so about more in a broader context what we research on. Locations, we are located at 3 sites in Switzerland. Dübendorf is the biggest site, close to Zurich. And then we have in the eastern part of Switzerland, we have also a site with about 260 co-workers, and Thun with about 80 co-workers. And so we are spread it a little bit over Switzerland. We belong to the ETH domain, and maybe you do not know until now Empa, but for sure you know ETH Zurich and also EPFL in Lausanne, the 2 schools we have, the 2 technical universities, educating a lot of students and are also really highly ranked in the international rankings. We have the Paul Scherrer Institution with the large-scale facilities, the synchrotron facilities. You might also know WSL, very special for Switzerland, for forestry, snow and landscape research. We have ERWAG for water research, also here in Dübendorf on our campus, and Empa for material science and technology. What you see here, the numbers, is the share of base funding we receive. Most of the funding goes to the schools, but we also earn quite a lot of money by third-party income and also direct industrial collaboration. So what is our motivation for what we are doing? So the cockpit for our research for sure are the United Nations Sustainability Development Goals that are tackling the prime challenges of our time. And with our research, we are tackling quite part of them. So especially in the health sector, of course, also for high quality education. Energy is a really important topic at Empa. Everything that is also with the climate action, responsible consumption and production, resource efficiency, really important for us. Also the sustainable cities and communities, and industry, innovation and infrastructure. We see us as a driver of innovation for Switzerland. As I said, bridging research and applications. We are working in 4 research focus areas, nanoscale materials and technologies, the built environment, energy resources and emissions, and health and performance. And what is important next to the UN sustainability goals is that with our research priorities, we represent almost 50% of Switzerland's GDP. So we are really working closely to industry, tackling real problems. So we understand us as the place where innovation starts. This is our vision. What are our unique selling positions, our USPs? So what we are doing, I told you at the beginning, we are organized in a matrix organization. We have a quite of individual disciplines, lot of basic competencies. We have physicists, chemists, material scientists, biologists, engineers. And the problems we are tackling and that come from industry and also from society are getting more and more complex. And with our matrix organization, where our research focus areas are horizontal, combining all the individual disciplines, we are able to bring the competencies together and to tackle then the problems and find solutions. And then bridging by making the knowledge and technology transfer to industry and to society and coming to really practical applications. So this is the way we function. We have a sustainable future thanks to new materials. Around 70% of all innovations worldwide are based on new materials. For example, when it comes to efficiency, more efficient photovoltaic thin film cells, we are developing more sufficient infrastructure with getting more lightweight, with stronger structures. What you see in the middle is a driller that you can use for surgery in the inner ear. And this is equipped with sensors. And when it comes close to the nerve, it starts drilling so that you cannot hurt the nerve productivity. So we start to produce even buildings with drones, with robots. This gets also more digital and completely novel applications like aerogels for insulation purposes, or even going into metaverse with electroactive polymers. We can really sense virtual worlds. So a lot of different things and really important new materials for the future. Often when we start from basic science to innovation, it's a long journey, and this is why we need also kind of institutional memory. This is important. With the 1,000 co-workers we have about 500 to 600 entries, and also people who leave Empa every year with the PhDs, postdocs. But we also have people that are permanently employed, and I think this is important, and that stay for a really long time. Head of labs, the group leaders, senior scientists, technicians, and they can follow up also activities over a longer term till they are really implemented in industry. And this takes often 10 to 15 years, and I give a few examples. For example, the electroactive polymers, artificial muscles, this took us around 15 years. In 2005, we already had developments here, a wrestling robot which succeeded against a student in a wrestling competition, going over a blimp, and then later on a startup company, a spin-off out of Empa, strategic cooperation with Datwheeler, and then acquired by Datwheeler in 2022. So it can take pretty long till it's really implemented in industry, and then you need persons who can follow it over a longer term. Another example, our aerogel material for thermal insulation. This is a material highly insulating. We developed an insulating plaster already in 2009, and then had the first industrial project and a market entry of a first product. Also won a sustainability award with this, and developed an aero brick. And now it comes also to application. We have a spin-off company, and we have now also our translucent bricks based on aerogel. This makes it possible to build really aesthetic translucent walls that reduce the need for artificial lighting inside the building. So really nice. So they have high insulation properties, and also you have light inside your building. So I find this really a beautiful application, these glass bricks filled with this insulating material. Also, what took quite a long time, but I hope you will all have a wooden credit card soon, is wood with novel unexpected properties. And this comes out of also the activities in the lab. I had it in the past. In 2011, when I started as head of lab at that time, we functionalized wood to bring a broader spectrum of application possibilities to it. We had a national research program on the resource wood. And then we had a person who said, I want to make a spin-off company, Swiss Wood Solutions. They made an artificial tropical wood out of Swiss wood with a densification process. And it's really a nice mechanical properties, first products. And now they really come into fly with a relocation after incubation on the Empa campus to a new site, where they produce wooden credit cards, and they are now on the market. And I hope, of course, that you replace also your plastic cards soon by these wooden credit cards. They are really beautiful. It can take long when it comes to material development until it's on the market. But when you develop software solutions, then it's all about speed. And here I will shortly present our spin-off company, Vibo. And here we had a nice playground with our Nest. I will show you later a little bit our technology transfer platform for sustainable construction. Here we install units that are dedicated to specific topics and where people live and work inside. One unit is UMA, where we work with recycled materials or materials that can easily be recycled. And then we had a PhD student, a motivated PhD student, a motivated master student, and they used this as playground to develop a self-learning predictive control algorithms in this unit, and where you can have heating and energy savings, because this is then with the thermostats in combination. They founded the company even during the PhD thesis, and we had the concept validation in our office building where we could save in the winter 21 to 22, 23% of our heating energy. They had a successful seed round and now really nice partnerships. So the software solutions, we need to be fast and have speed. And also here are a lot of possibilities to be more efficient, for example, with our energy system, and thus becoming more sustainable. Also an example is from graphene nanostructures to quantum applications, quantum computers. 12 years already. We started with developing completely new materials with these thin graphene nanoribbon structures, and by changing the geometry, we are changing also the electronic properties. Have first components, got a 15 million grant from the Werner Siemens Stiftung for development of novel graphene-based quantum computers, and this really goes now into devices. So it takes quite some time. What is our USB and in the DNA is really the knowledge and technology transfer. This is important for us, and people who work here at Empa, they come because they see a purpose and they want to be part of something that has really impact at the end. And how we understand knowledge and technology transfer is that it needs the people. They are in the center. They are doing knowledge and technology transfer every day with giving lectures, with the public relations, with teaching, with spin-offs they are creating out of our activities, some patents, the research and development projects, etc. So this is really important. And what is also important, our partners. So we have an extensive network of industrial partners, a lot of new corporations every year, a lot of Swiss industry partners, contracts with Swiss industry every year, a lot of events also in our academy. So this is important. And I can also show how this is related to countries. So we have, when it comes to cooperation with industry, most of our collaborations with Swiss companies, but also 27% with European countries and 38 or 6% with the rest of the world. With academia and public bodies, we have especially collaborations within Europe with European partners. So also it's really important for us to be part of the European framework programs again, and Switzerland, and 6% with the rest of the world. The secret of our success are our researchers. We have researchers from about 55 different nationalities. And as I said at the beginning, with different backgrounds, and when we bring together these competencies, then you can develop really great things. So people are in the center. And some numbers I told you at the beginning, we have about 1,000 co-workers. We are also have about 43 apprentices. We have among the 1,000 co-workers about 600 researchers, including also bridging professors like I'm also bridging professor to the schools, ETH, EPFL especially, but also other universities, more than 100 postdocs and about 280 PhD students at the moment. But we are not providing the title. This is also why we need these bridges to the schools, as the schools are then providing at the end the PhD titles, but we are doing the technical supervision. What is also important always in science are scientific publications. It's important also to stay on a good level, and for the CVs of our researchers really important. I already told you about the contracts with industry. Also important, the third-party funds we get with the ongoing projects, starting from Swiss National Science Foundation, InnoSwiss projects. These are projects together with industrial partners, and also the European projects that are really important for us. We have 2 incubators where we support 34 spin-off companies out of Empa activities at the moment, and they find for the first 5 years a home at Empa, and after the 5 years, then generally they can be independent and are looking for new locations. We receive 107 million base funding, and we earned in 2022. We do not have the new numbers for 2023, but it's similar, about 60 million by third-party mean income. What is also important next to the funding agency is our Zukunftsfonds, where we promote talents, and we want to support young talents and thus implement more of our innovative ideas faster. And through our Empa Zukunftsfonds, each one can contribute also directly to solutions in the topic sustainability, health, energy, and nanotechnology. I have a few examples. For example, Lukas Gerken, who got a Young Scientist Fellowship from Empa for a gentler tumor treatment. So it's cancer treatment. And if tumor cells could be made more sensitive to radiation, treatment would be more effective and gentler. And they are using metal oxide nanoparticles as radiosensitizers and can also produce them in between on an industrial scale. And in oncology, there are hopes on the supportive effect of hafnium and gold, and you bring them directly into the tumor and then have a better treatment by the radiotherapy. And they are not harmful to healthy cells, but they are really effective for tumor killing. Another very nice example also out of the health sector and also from a young talent we supported. He got an ETH Pioneer Fellowship, is a sensor patch for internal wounds after a surgery. And this polymer patch is equipped with sensors that warns when the wounds in the abdominal cavity starts to leak after a surgery and closes then the leak independently. So really nice. And he also in between started the spin-off company. Our flagship projects, and this is also USP of Empa, that we do not only want to develop materials in the lab, we do not know then if they really function. We have our research and technology transfer platforms to validate. One is our Coating Competence Center. In our Coating Competence Center, we make tailor-made surface technologies and advanced manufacturing processes fit for industrial applications. And here, industrial companies are providing us the equipment so that we can really showcase on a demonstration level that something works what we developed in the lab. An example out of our manufacturing activities are insoles with sensors out of the 3D printer. Here, researchers at Empa, EPFL, and ETH Zurich have developed a 3D printed insole with integrated sensors that can measure the sole pressure in the shoe. And why is this important? It's important for athletes and also patients after surgery to determine performance and also the therapy progress. And here also the cellulose comes a little bit into place out of my activities. And what is nice with this approach is that thanks to the 3D printing and different inks we developed here, we can print it in one single step, complete with the cabling and the sensors. Nest is maybe our most visible technology transfer platform. It's a building and innovation platform and a platform of Empa and EAWAG, our water research institution on campus, where we validate new building technologies and construction and energy concepts to optimize energy concepts, energy flows. And it works like this, that we have different units that are dedicated to specific topics like resource efficiency, the reuse of materials, solar energy harvesting over the facade, or here really thin concrete structures that are flexible, also solar energy harvesting by the facade. So it's really nice. And what is important is that people work and live inside and can experience then the materials and technologies in the daily life. And sometimes you have to go back to the lab and develop it further. And in some cases, we can then come faster to the market, as we have about 150 industry partners in this technology transfer platform. One example is now we are going into CO2 negative materials in the building sector. It's important when we really want to come to net zero. It's important that we try to get the CO2 back we have in the atmosphere. So even when we come to net zero, we have too high level of CO2 in the atmosphere, so that it's difficult to stop the temperature increase we have at the moment. And the building sector is the most material-intensive industrial sector and the major driver also of global warming. It's responsible for about 40% of global energy consumption, 30% of greenhouse gas emissions, 36% of the waste generated in Europe. So we are developing at the moment new materials that can serve as a CO2 sink. And this is as example here from plant waste materials. We develop an insulating material, coal-like material that can serve as insulation, and later on after deconstruction it can even be a soil enhancer and actively absorb then heavy metal ions, for example, in the soil. So here you have CO2 for a long term bound to the material. Our eHub, a platform for innovation also, where we look for new technologies for the production, conversion and storage of energy and optimize them for their practical suitability. This is also a really important thing as we optimize energy flows and district level, how we can find the right energy mix when it comes to an energy transition. And this is linked directly to MOVE. So where we can, with excess energy by solar energy harvesting, we can use it to produce hydrogen and liquid fuels. We can have in between a CO2 capture plant here, where we capture CO2 from ambient air with Climeworks, the startup company in Switzerland. We can produce methane, so synthetic fuel. We can even split this again to get hydrogen back, and solid carbon that can be then part of our materials, where we also have then a CO2 sink in our materials. So we look here for the mobility of the future without fossil energy and with closed material cycles. That's it. So my input from presentation, what we are doing at Empa, and I'm really happy to discuss with you further and to answer your questions.
So thank you, Tanja. Please, if you have questions, I have thousands of questions, so we have some time, so we will anyway do a Q&A. So I moderate this in any case, but if you have questions, please write them under questions and answers. Now, Tanja, this is super impressive. Again, I think it's what you said, that I think 40% of innovation is based on changes in material science. That is just showing how important this research is. Now, on a global level, are you guys really good, or you're like average, or I mean, there's other institutes. How would you see that?
This is, of course, a good question. Of course, there are larger institutes than Empa, and nowadays it's all about also collaboration between different partners to find solutions. So it's not about. Of course, we want to be good, and we are good, and we are known also in the other countries, because we are really world class in specific niche applications, I would say. So we try also to find our way. I told about the carbon graphene structures, so to get the Werner Siemens Foundation fund, we got it because we started something that nobody else is doing. So something absolutely new, totally new materials. And this is also how we work. We really try to make something unique. Also with our Nest technology transfer platform, this is something unique worldwide. And a lot of people come from other countries to look at this as example, and also maybe copy it somehow. So I think what is unique is this with our size is that we can combine the different competencies and bring then really unique things forward. So yes, I would say we with our competitors, we are in a good situation, and we are also known there. But again, it's not that. I think we must come away from how we are better than the others and not talking to each other. We must all work together, because only like this we can face the challenges we have, and tackle the problems and solve the problems we have, and we work together.
Now, of course, coming to the usual question, and also we have European friends here. Now, not being a part of Horizon is probably a bit of a headache. And how do you see this? So yeah, I guess you put big hopes into the new, negotiations we conduct.
Yeah, this is really important for us to be associated again. So even though we have the replacement programs at the moment in Switzerland, and I must say they helped us a lot. For a certain time, they help, because we still had quite a lot of European projects, as the part of Empa, or the Swiss part, has been paid by our national agencies. But still, there is a kind of erosion after a time, as we are not part of the excellence program, especially these ERC grants. These are excellent grants for excellent researchers, starting grants, consolidator grants, also at the end for really experienced researchers. And here you measure yourself with the best researchers in Europe, and at the moment it's then in Switzerland, and it's different also in your CV. And we see also that experts sometimes say, okay, should we really come to Switzerland at the moment, or better stay in a country where there is an association? So it's really important that we will be associated again, also for programs like space, quantum, where we are excluded at the moment. So we have big hopes into these new negotiations, and we are also thinking things should not be mixed up. So research is really important, that the best players are working together, and this is it's not about politics.
Yeah, of course, it's funny when we talk. When I also personally talk to European politicians, etc., I always tell them, do something for that, because I truly believe I just asked this question because what you were mentioning is that the best people need to collaborate together, and I think this is in the interest of Europe, and it's interest of Europe to become again a center of innovation in the global landscape, and this is not the case. in many ways. So taking like the world's most innovative country out of the picture from the Europe side is maybe not a good strategy in terms of, but it's not the way that people think. But anyway, have another question. Thinking about AI and all that, how has your research changed with AI, and how do you go about it because it's so dynamic, etc.?
Yeah, this is a good question and an important question, and this is something we're discussing at the moment in the whole domain, how we can bring our AI activities we already have together, maybe also in a digital institute that can be close to the for research institutions. So AI is in our life and in all research labs we have. For example, when it comes to machine learning plays a big role to make products better, to have maybe a forecast on how an enzyme reacts in a specific function, etc. We have the digital twins that are really important for us. When it comes to the energy transition, it's important that you can model and simulate how where you have the greatest impacts. For example, we are making at the moment a digital twin of the whole Empa campus as we want to become net zero. We are in discussion with cities like Winterthur here in Dübendorf, of course, to make a digital twin of the cities so that we can see where we would have the greatest impact when we make some measures in the energy transition. So AI is really everywhere, also in all the digital fabrication topics, how to be more resource efficient with the 3D printing, with the new advanced manufacturing technologies, etc. But here important, it's also to have some critical mass, and we at the moment using a lot of these models and tools we have, but to have a critical mass and to bring together what we have, the AI Center at ETH, we have the Swiss Data Science Center, we have CSCS for the hardware, for the big computer installations in Ticino, etc. And somehow to bring this together. And do not forget to work on these language models. So ChatGPT and everything what comes next is I think we can even not imagine what is coming there.
Yeah, it's crazy. But would you say that the innovation circles have accelerated by using AI? Or is there something that you kind of feel, even though you might face hallucinations, etc. of this AI elements? But what's your feeling?
I think innovation circles have accelerated a lot. So it's really helpful, and it's really helpful also for the companies. So when they want to optimize products, for example, out of my sector in wood, when we started with the machine learning, we had Pavatex, who was well known for their insulation boards, and they said, oh, we get quite a good quality out, but we do not know why. We do not know what happens when we change temperature, humidity, all the different factors. There are so many. And how could you help us? And when you then have there these learning algorithms that can help and better understand how process technology works and how different factors can be influenced, it's really, really helpful and very important. And
Cool.
also, yeah.
I mean, maybe a last question from my side. Now, how does, for example, the countries from Central Eastern Europe, is there any collaborations or, like, say, scientific exchange, or you have lots of, PhD students from the? How do you see this? This relationship to the region of our Chamber of Commerce?
Yes, as we have collaborations. We have collaborations throughout Europe. We have, for example, with Poland, we have also a PhD program, and this goes often over researchers we have. As I said, we have the 55 nationalities, and we have then professors that have a professorship. Maybe at Warsaw University, and then you can collaborate together and make memorandums of understanding, and then create something together. We have these collaborations, but they are spread out somehow. So it's not that I could say or.
Yeah, no, I don't. I didn't want to put you on the spot there. So anyway, I think it's a quarter to 12, and I can only invite you guys if you're around oh no, maybe one last question if you have you personally. How do you see the potential now with the innovation park in Dübendorf coming? Is this good for you? Lots of potential, or how do you see that? Any joint projects you guys having? Just for the people that might not know it, Switzerland has 7 innovation centers or parks. I hope I say it the right way. And then one is actually, and then the biggest one probably is going to be built on a military airport around Dübendorf, very close to where Tanja's Empa building are, and Nest is that we see on this picture. And anyway, they have been struggling a bit to build it, but now I think things go ahead, and it should be one of Switzerland's most important innovation centers. And so I wonder where, what this would mean for Empa.
Yes, I see it as really, really important, and also for us, for collaborations, we should have one thing that is now one first thing is a space center there, and we already have collaborations, and it could be a chance for spin-off companies maybe to find a home then also after incubation at Empa, or even have the incubation over there. I'm also in the Stiftungsrat at the moment only as guest, but it's important for us that we also bring in our research ideas, and at the moment when they are planning all the buildings, so that we can also bring our sustainability topics in. This is an important question. I hope that this works, and I think it's the only place in Switzerland where we have so much space, and where really something big could be created at the end. So
Cool.
At the moment we have the halls, and the halls are not so important for us. We are also at the moment in our master plan, we built a new lab building where 3 labs can move in. So we do not have at the moment a space problem here, but working together with companies and spin-offs that could be settled there. So really important.
Cool. So thanks a lot, Tanja. And I also thank everybody for having joined us. You will get the follow-up. You can review the video, and we will contact you about the next impulse sessions. If you got any ideas how, maybe you can collaborate, or you're interested for collaboration, or if you can do anything to help Switzerland get back at the table at Horizon, do it. And Tanja, so thanks a lot, and we stay in touch, and I'm really looking forward to all the good things that you will do for us and the world at Empa. Thank you.
So thanks a lot for the invitation, and yes, please help us when you have any impact.
Okay, so bye everybody.
Bye.